Hey there, Asker here. So let's continue from where we left off in the last lecture. So in this lecture, we are gonna be completing our game over and collision of our player. So let's start. Let's create a new method, private void game over below our update method, private void game over. Also, first let's take a look at the game object that we will be instantiating when our player gets destroyed. So here we have this sphere 2 under our 3D models. As you can see, it has many different sub game objects inside of it, and we are gonna be using them to create that shattering effect. So we are going to add a mesh collider and a rigid body to every sub object and set the mesh collider to convex. Yeah, that's it. Now let's play, and boom, you can see the shattering effect. And now let's change its scale to 0.45 on the x, y and z, so that it is close to our player size. Play it. Okay, this looks perfect. So now let's change its y position to 0.55 just for testing purposes, and also unpack the prefab, unpack completely, and rename it to breakable player. And now make a prefab of it and drag and drop it inside of our prefab folder. Open up our player controller script and let's refer to our game object, public game object breakable player. Now inside of our game over method, game object shatter sphere equal to instantiate breakable player transform dot position. We are only instantiating the shattered sphere game object at our player's position, and also write coordinate dot identity. And for each transform, for each of the transform object inside of our shatter sphere, we are going to add some force. To transform objects in shatter sphere dot transform, we are gonna set objects. Oh, sorry, object. Yeah, object dot get component rigid body dot add pose vector 3 dot forward into 5 and force mode dot impulse. Yeah, that's it. And outside of the for each statement, let's set can move to false and also game over to true. Get component mesh collider dot enabled equal to false. We are just disabling our player's collider and mesh renderer. Okay, get component collider dot enabled to false. And also let's make that slow motion effect. So set time dot time scale equal to 0.3f. Also let's set the time dot fixed delta time, so that there won't be any glitch in our time, and set it to time dot time scale into 0.02f. Also, let's reset the time.timescale in our restart, that is inside of our fixed update, sorry, inside of our update method, inside of our second if statement. We will set time.timescale equal to 1, and also fixed delta time.fixed delta time equal to time.timescale into 0.02 f. That's it. Save your script, and let's create a method for our collision detection. So private void on collision enter. Let's write an if statement. If collision dot game object dot tag equal to enemy. Also we will check if not game over, then we will be calling our game over method. Okay. Now let's also create a private void on trigger enter. This will be used for our finish. So as soon as we finish, we will call a new enumerator. So if other.gameObject.name equal to finish. Make sure you copy the perfect names as you have in your inspector. Okay. So start coroutine. Next level. For now, we are going to comment this. We will come back to it later. And also just change the mesh collider to mesh renderer inside of our game over method. Okay, so now let's test it out. As you can see, okay, yeah, the collision is working perfectly fine. So we also need to stop our camera from moving, and also we will be fixing these light issues in the later lectures. So inside of our camera movement, inside of the update method, let's write an if statement. If find object of type player controller dot can move. If can move is set to true, then only we can move our camera. Okay. Now let's test it out once more. Okay. And as you can see, our camera also stops moving and everything seems to perfectly work fine. Okay, so now we will be adding a background image for our game view, and we will be changing its color dynamically. So let's drag and drop the square inside of our camera parent. The square is inside of our textures folder. So now rename the square to background and set it on the Y to -8 and on the Z to 88.4. Set the rotation to 90 degrees on the X and scale it to 60 on the X and 286 on the Y. Okay, as you can see, the game screen is covered entirely. Let's create a new C# script. Name it to background image. Okay, now open it up in Visual Studio. Before, make sure that you have the RGB value set to 0 to 1 inside of our color. Now open up the script. Private color, random color. We are just going to set the RGB values to random color. So inside of our start, random color equal to new color, random dot range. We'll set it to 0.1 to 1, and we are gonna set it for the R, G and B values. So copy the random dot range code for the G and the B values. Okay. Also, let's get the image component. Get component image. We need to import that. Using Unity engine.ui image dot color, and we will be setting it to random color. That's it. Now let's drag and drop the script inside of our background, and now let's test it. Okay, something is wrong. Okay, so we have a sprite renderer. So change the component from image to sprite renderer. Okay, now let's test it. Okay, as you can see, the color has changed. So now for every new level or for every new game, the color will be different. And don't worry about the position because it will be moving with the camera as it is under our camera parent. So you can see in the inspector also. And that's it for this video. We are gonna be completing our entire game in 7-part series. So stay tuned. Don't forget to subscribe. Augmented reality tutorials coming soon.